60, what am I missing? 64, let's do it. So 64, certain type of bacteria, dPdt is equal to K, T to the 1/2, hate square roots, getting rid of that right away. Initial population size, so the population at time equals 0 is 500. Notice I'm writing that right away. Not even just waiting to put it in the equation, I've got it. After day 1, the population, oh, this is interesting. After day 1, the population is 600. Estimate at day 7. Agreed? All right, so this is weird. Let's try this thing out. So what would be my if this is my change in population, what's my population equation? Population equation would be make this T to the 3/2. K is just a constant, right? Divided by 3/2, so that would be 2/3. Do you want me to write that in 2 steps? Okay, so 2/3 plus my initial population. Agreed? Plus my constant. Now, what's weird about this is they didn't give me what K is. So what am I missing? How can I solve for it? Kennedy? Okay.
Oh. You can.
So we know what is at 0. If I put it 0, I get 500 because this all goes away. I get 500. If I put in 1, I should get 600, right? So let's put in 1 and see if I get 600. See what makes it 600. So 600 equals 2/3 K times 1 to the 3/2 plus 500. Agreed? Move that across, I get 100 equals 2/3 of K. Flip and multiply, I get 300 over 2 equals K, or K equals 150. Agreed? So now that I know what K is, I can solve for what happens at day 7, right? Yeah. Let's do it. So population equals 550. This is 100. I'm going to simplify one more step. Agreed? And then I'm going to plug in 7, which is going to be nasty. Probably going to need a calculator for this because I don't think the square root of 7 is something I know. At least not well. So 7 up caret parentheses. Make sure you use parentheses beginning as 3/2. End parentheses. Whoa. Didn't expect that big a number. You got it anyways. 1852.026 plus 500. So my population would be 2352.026. Why am I going 3 past the decimal point? Because you have to. It's calculus.
I can argue it says estimate.
Okay, when they say estimate in the calculus test, what are you going to do?
Have 3 decimals.
Yes. Unless they say estimate to the nearest whole bacteria, or they give you some out phrase. If they don't give you an out phrase, you're going to go 3 past the decimal point because that will never be wrong.
Whole bacteria.
By the way, if they give you estimate to the nearest whole bacterium or bacteria or whatever it would be, you would stop here. You can stop here, or if you keep going, they'll still accept this is the right answer. So if you keep going, you're never wrong. If you go 3 past the decimal point, you can't be wrong. So do it. Even though it's a silly statement, right? Make sense, everybody? Kennedy good? All right.
Hey, what's a volt's terminal velocity?
The association of gravity of planet Earth, the surface is negative 9.8 as we measure it in meters per second per second. Wow, that's weird. Okay, if a boy climbs into a 10-meter tall building and throws a ball upwards with a speed of 15 meters per second, find each of the following. So the acceleration at 2. So I plug it in the acceleration equation, which is negative 9.8. I plug a 2 everywhere I see a t, and I get nothing. So I get negative 9.8 meters per second, or whatever that notation was. All right, for those of you who are playing the home game, you can also write it like this. Who knew? Good? Then the next question is, what's its velocity? How do I turn acceleration to velocity? So the antiderivative of this equation would give me my velocity equation. Agreed? So that's going to be negative 9.8 t, raises power by 1, plus my initial velocity. So this becomes negative 9.8. What was my initial velocity? 15. So this is my new velocity equation. Agreed?
Yeah.
So now I'm going to plug in 2 to find my velocity at 2, right? So my velocity at 2 would be equal to negative 9.8 times 2 plus 15. Agreed? 19.6, so negative 4.6. Units would be meters per second. I lose one of those per seconds because I changed my rate down 1. Hope everybody's hearing this and everybody's got this because this is great stuff. I'm going kind of at a weird thing, and I think I see other people looking down the papers that I'm worried about, but that's okay. Okay, so velocity time. Now I want to change it to displacement. How do I turn velocity to displacement? I'm going to integrate again. So integral velocity with respect to time is going to be displacement. We'll call it y. Okay, y of t. So if I integrate this, I get negative 9.8 t squared over 2 plus 15t plus, what's my initial displacement? D naught. Oh yeah, I put a D naught on here. Or why not? I'm going to go why not. You said D naught, but I'm going to go why not.
Oh, yeah.
We seldom use D because of the D gets really weird. Okay, so I'm going to go why not. And then what is my why not? It is 10. Agreed? So if I want to know where I am at time equals 2, what am I going to do? Plug it at 2. Negative 4.9 times 2 squared plus 15 times 2 plus 10. So that's 40 minus 19.6 is what? 20.4. I like that. 20.4 meters. Again, I lose another per second because I'm now talking about losing another level of rate. Got it?
Yeah, thank you.
Awesome. Has everybody got this one? Because if you got this one, we're going to have a bunch of hundreds on the test. It'll be great. Except for the 8 people that are missing. That might not be so great for them.
Don't forget your.
Okay, time-wise, we're right against the barrier. All right, so I'm going to plan a fairly easy period tomorrow. We're going to finish that worksheet that you have in front of you. We're going to go over some other things you need to know, and then we'll be done with the chapter before we even take the quiz. So the quiz is now looking like it's going to be Thursday, test Monday, Tuesday.
This Thursday?
This Thursday.
This Thursday.
This Thursday.
No, it's not.
We've got nothing else to learn. We've got it.